This is the second part of the second lecture, and here we're going to talk about the perception of forms. So, as you probably have gleaned already, there is all manner of complexity in the brain when it comes to processing visual stimuli and probably even beyond that. When it comes to the perception of forms, though, the brain is going to go a step beyond even what we've covered so far. A good way to think about this would be to take a moment and consider the fact that the image that is projected onto the back of your retina is a two-dimensional image, yet somehow the world you perceive is in three dimensions. And how exactly is that happening? Ultimately, your brain is adding or creating new pieces of information that allow it to perceive in three dimensions, even though the input it is receiving is a two-dimensional input. This is an example of what has been coined beyond the information given, and it refers to the brain's ability to create perceptions that include information that is not actually included in the stimulus itself. Now, an example can be seen through something called the Necker cube. This is an example of a reversible or a bistable image. This just means that this image has either, well, in this case, two, seeing as it's bistable, or reversible, it can oscillate between two different orientations. So, turn on the pointer again. This is the representation of the Necker cube here. And if you look at it for a little while, you will see that it can actually hold two different positions. One in which this square represents the front face of the cube, and then also one in which this square represents the front of that cube. Here are two representations of both of those cubes drawn without the back lines. Now, you can look at this for a little while, and you can probably, after a little bit of time, start to bounce back and forth between these two different orientations, which is why this is called a bistable image. But here one gets evidence of the fact that the brain is adding additional bits of information because the cube itself does not actually contain orientations or a three-dimensional shape. It is a set of lines that are drawn on a flat plane. There's a square here and a funny trapezoid there, a triangle here, again a trapezoid, another trapezoid, a triangle, a trapezoid. That's all the actual information that is there, and it is in two dimensions once more. Yet we're able to see this as not only a cube, but a cube that occupies two different orientations in space. Now, interestingly, with these types of images, it is considered to be impossible to hold both of the images in mind simultaneously. What this means is you're unlikely to be able to perceive both orientations of the cube at the same time. Another example of this comes from another ambiguous figure. This is also a bistable or reversible image. And here you can see that if you are focusing on the white as being the primary object, it looks like a vase or a goblet of some kind. Yet if you look at the black as the foreground or the primary object, you will see two faces in profile shown here. And depending on which one you're focusing on, you can change what this image is ultimately showing you. And this is just another example of a bistable image. And specifically here, though, we're focusing on what is defined as background and what is defined as the actual foreground or the object or focus of our visual perception, I guess. This is also referred to in this specific case as figure and ground organization. And just a moment to consider, one takes so readily for granted that we are able to look at all these various objects that are most likely around all of us right now, yet we have absolutely no trouble distinguishing between what is background and what is not. If you're sitting at a table with some various things on it, you can see all of those things are on the table. You don't ever think of them as part of the table. Vice versa, or not vice versa, but you could be sitting on a bed too, and you don't confuse the fact that there is a bed which is the ground and all the random things strewn around you on the bed are distinct and on top of that bed. Ultimately, though, that is an automatic series of processing that is going on because as far as your retina is concerned, they're all in the same sort of plane. Now, I touched on this a little bit, I guess, with these examples I just gave of the table and the bed, but one often tends to think that these types of things only happen for these fake examples like bistable images. But in fact, Our brain is always filling in additional information and allowing us to pretty much spontaneously interpret the world. So here you can see there's a bowl of fruit with a vase behind it, a pitcher, and then there's a wall with some funky lines on it. Now, chances are you do not believe that this banana ends with this shape, but rather there is a point of the banana somewhere over here. You additionally don't think of this apple as being two separate apples or that it's chopped in half and but secretly hidden behind the banana. My guess is you also don't think that this pitcher is attached to the back of the bowl and doesn't actually have a bottom, nor are you likely to be surprised if these lines are continuous if you were to move the pitcher and the bowl of fruit. Now please note, all of those interpretations are not actually present. You cannot see the lines, or the bottom of this vase, or the complete apple, or the bottom of this banana, as illustrated with the outlines shown here. The D banana, see, that's the true ending of the banana you're seeing. B and E represent the other sides of this apple, and the picture only goes down that far. So pretty much everywhere you go, you are always adding additional information into your visual perception above and beyond what is directly available to you from the stimulus itself. Now, your brain doesn't organize and infer things chaotically, it does so according to some principles, and these principles are often referred to as the Gestalt principles of organization, or just abbreviated to Gestalt principles. And there are 5 that we'll talk about here. The first is similarity. If you look at these 16 dots, chances are you see these as 4 vertical lines of alternating color. You probably don't look at them as 4 rows, each with alternating colored dots. Even though you could maybe force yourself to, the image that pops out most strongly is of 4 sets of vertical lines. This is similarity. Now, proximity refers to how close things are together, and here one probably notices that there are 3 clusters of dots, instead of thinking of it as just one oddly shaped series of dots all put together. This is when things are sort of close together and have a little bit of increased distance between that closeness and the next set of things, we tend to perceive them as separate things. Another principle is good continuation. This is similar to how we thought the pitcher continued on behind the bowl of fruit and those lines continued behind the pitcher. It is unlikely that you think that this green rectangle is in fact 2 separate green rectangles that have been glued to the sides of the cylinder. In fact, the visual perception most likely looks like a cylinder that is in front of some type of rectangle that is behind it. We tend to imagine things are continuous even when we cannot see them, as long as it of course makes sense. Closure is another one. Here there's no actual triangle, yet we perceive this as a triangle. These are in fact just 2 different shapes that are oriented in a way the vertices would make a triangle if you were to draw and fill in those lines, yet we still perceive this as a triangle, even though it's not there. So if a shape is not entirely complete, we will tend to complete it for ourselves, much like the banana or the apple. Next is simplicity. And this just means that we prefer to organize things into shapes that are simple, like 2 rectangles, than an oddly shaped structure that has lots of different vertices and odd angles. Now, it is true that we all apply our own interpretations to the world based on our knowledge and understanding and upbringing and so on and so forth. But when it comes to the basic principles by which we organize our visual world, we're all playing by the same rules, and this is one of the reasons why we pretty much see the same world no matter who we are or where we go, at least most of the time. So, looking at this, and you'll probably catch on pretty quickly, seeing as how we've talked about parallel processing so much, but we have talked about how the brain is able to infer extra information beyond just the stimulus that is given, and so we're likely to first perceive the world and then interpret it in some way that allows us to add that information. But that would be incorrect. This would be, if you wanted to think about it like this, the case of a chicken and an egg happening at the same time. They're basically parallel systems running, and both of these systems, the perceptual aspects and the interpretive aspects, are both influencing each other. Remember those bidirectional arrows, that were between the various different areas in the visual cortex. They pointed in both directions. That is true here as well. The perceptual set is influencing the interpretive set and vice versa. Here's an example to show how interpretation can actually guide perception. So if you look at these little black figures for a little while, maybe you already see the secret here. But if not, think of another word for to pick something up and see if that changed all of a sudden. And if it still didn't change, no worries. Think about the word lift and now look at it closely. Do you see that word presented? All of a sudden, if you do, you have organized your perception in a certain way that originally wasn't the case when these were just a bunch of weirdly shaped black block things. But once you interpreted it in a certain way, either with my clue of how to pick things up or when I just said lift, you change your perceptual awareness of this image. And this is how the FedEx arrow works. And if you've never seen this, that's okay. Just next time you see a FedEx sign, just think about an arrow and it will probably pop out. I remember it was only a few years ago that someone told me about this, and up until then, I had looked at a FedEx symbol for who knows how many times and never once seen that arrow. It was only until I was given a new interpretation of that sign, symbol, logo, whatever it is, that my perception of it changed. Of course, now I can never unsee the arrow, and whenever I see it, I always see the arrow as well. But again, it's because I can no longer uninterpret that stimulus as it was. Another example of this is here, where you can, without any trouble whatsoever, read the word perception. Yet if you look very closely and specifically at the various pieces of information given, it doesn't actually spell a word. These are just a bunch of weirdly angled and curved black lines of varying thicknesses, right? For example, the C looks like a crescent this way and another crescent this way, but we still see it as a three-dimensional C, and thus read the whole word perception. Now, perception isn't actually there. This is not something that is represented on our retina itself, right? All that we see on our retina is a different set of dark splotches on a white background. Yet we still read perception without any trouble. This is yet again another example of how interpretation can lead perception. Now, it is important to note that I've shown you two examples where interpretation comes prior, or it seems like it at least. But again, please remember, both of these systems are always working together to try and allow us to understand the world that is in front of us.